Okay, thank you very much. Okay, so we will start. So first, I'll start with my introduction. So my name is Dr. Nagen Kuswaha. I am faculty at Department of Electronics and Communication Engineering, Indian Institute of Information Technology, Pune. So uh, this course, briefly tell me about this. Let me tell you about this course, and then we'll start. So this course consists of 13 technical sessions and one session on life management. And out of these 13 sessions, 6 will be taken by the researcher from the or the academicians from the different institute from USA. So there may be a slight change in the timing as well, but still I'm trying to manage the same timing which I have given to you, right? And the timing will be uh, informed you in advance, right? So let me start my presentations. Okay, before announcing that, one more thing I want to announce is the person who have got the confirmation for their participation will only receive the certificate when they have the 80% of attendance and 60% the marks out of the test. So the person who have not got the uh, confirmation from my side will not able to get the certificate, because it happens that in between you try to call me and ask for the certificate. Certificate is not issued by me, it is issued by AICT, right? So those who have already confirmed their participation, I have already sent the mail. Those people who will only going to get the certificate, right? So now we have already wasted a lot of time, and in fact, there is slight uh, a delay for the inauguration function. So I'll start with my presentation, and one more thing, my chat window is open, so if you want to ask any question, you can type it, and maybe afterwards we can also discuss. Okay. I got a okay. No problem. The once you have registered for this program, you need to have attendance 80% of the attendance and 60% marks. Uh, out of the test which will be conducted on the last day of this course. So I hope everyone will get more than 60% because the sessions will be going to be very much interacting. So let me start my presentation. Okay, for the bandwidth issue, for some people, I might be switching off my camera. Okay, so good afternoon, everyone. So today's the first session is introduction to IoT, right? So before starting it, I hope that everyone is aware of the IoT, but still I will go through some of the basic concept, and then we will move forward to the use cases also, right? So the outline of today's lecture will be we'll talk about the IoT, then we'll talk about the genesis of IoT, which is very much important, and the principle of IoT. That is, that is the core of this whole 5-day program, and we will also see some of the examples for this IoT implementation. And okay, so I'll start with, first of all, what is IoT? Whether it is internet or whether it is things, right? So when we talk of IoT, the first thing come into our mind is okay, it is something kind of internet, right? Okay, so basically, when we talk of IoT, that means the things will be connected together and things will be talking to each other, right? And when we talk about the things are the physical one. I'll start with my lecture with an example. uh, it is quite obvious example, but still I want to start it. Okay, now suppose you have a room, right? And you have chair and benches. Why I've taken the example of chair and benches, because if in our in institutes or in our universities, the chair and benches are two things which we commonly found, right? Now suppose in that room, right, suppose there is one chair over there and one window. Let me, okay, a window, and there are other object also like benches, right, and other objects are there. When there is no one present in that room, or maybe no one sitting in that room, so the light and air conditioner and the other equipment must be off, right? So usually what happens, in many places you can find that there is a sticker on the door, please switch off all the electrical appliances and the tube lights when you are leaving that room, right? Something like that, or some different form you might be found at many of the places, right? But if suppose we have planned such that the benches, the chairs, the other physical objects which are present over there, they start talking to each other, right? And after that they will decide what to switch on, what to not switch on, or whether we should completely switch off that uh, uh, the whole appliances. Okay, sorry for the interruption. I hope the PPT is visible. I am very much audible. If I'm not audible, please let me know. Okay, fair enough. Now, suppose a person enter in that room, right? Or many person have entered, and at that room there was a program, and after that program the people start leaving that program, right? So suppose after all those people have left the program, if by somehow by some mean, if benches and chairs talk to each other, if anybody is sitting at you, or if then they can direct the tube light or maybe the air conditioner to be switched off, or maybe they will judge the strength of the hall, right? Suppose there is a big hall, and there are many air conditioner in that, and many lights are there, and if the occupancy of the hall is small, the benches can talk to each other, and they can direct that whether this air conditioner should be on, or whether this light should be on. Now the point is how the benches and chairs should talk to each other, right? Because they usually they don't talk to each other, right? Point is how they talk to each other, if by any mean if we employ some of the sensor in the benches and the chairs, right? Suppose if we implant a pressure sensor in the chair as well as the benches, and once the person enter that room and occupy that bench or the chair, the chair will send a signal to someone. I'll tell you what is the someone. To someone that I am occupied and someone is occupying me. Similarly, the benches, right? And there may be the rows of the benches and the column of the benches, and accordingly the particular bench will specify whether the bench is occupied or not, right? So according to that, we will according to that, sorry, I think someone wants to join. Okay, thank you. According to that, the system itself takes a decision which are the things should be on and which are the things should be off, right? To be very specific, if I'll go with an example, okay. So now consider a case. I'm still on the previous case itself, and we have a system over there, right? And this system or this space compromises of many of the things, the things may be anything, like I again come with the previous example of chairs, benches. These rooms may be having windows and curtains, right? Now, if by some any mean, if we integrate all of these to a system, right? If we integrate all of these to a system such that they can talk to each other, uh, uh, the the system will become more smart, and the whole process of smartness is to uh, improve the either productivity or saves some of the resources. And suppose all those things are we can somehow we can combine, we will be we will be getting a good result out of that, right? Why I have given the example? Because due to because of this example, it is very much easy to understand. And now I'll again go to sharing of my. Now I'll come to the objective goal and the outcome of the IoT. And it is very much essential when we are going to learn about this technology, that is IoT, or when we are going to design about this technology. So the objective, the some part of the objective we have already covered. That the main objective, when I was talking about the previous example, the main objective was to have to increase the either the productivity or same some of the resources, right? The same objective we can see over here. And of course, all those technology of whether it is IoT or whatever the technology we taught, we see it's all about the betterment of the humankind, right? Now I'll talk about the goal. The ultimate goal of IoT is connect the unconnected, right? And this is the ultimate goal, because in the previous, when we don't have the IoT thing, we already have the connection from your mobile phone to your laptops or maybe some other devices also, and we are very with very ease we are managing all those stuff, right? Now, as the previous example, we have never thought of the chairs will be connected to the benches. So that was the goal. I mean, only I've given the chair and benches example. That doesn't mean that only we are going to connect chair and benches. In fact, we are going, I mean, for the IoT, the use cases are huge, and I will also discuss some of the use cases in the last part of my today's lecture, right? Now we'll talk about the outcomes. Now, if somehow if we are connected these objects by to each other, and we have integration of that, the accuracy as well as the efficiency and the productivity of the system will increase. So if we understand the objective goal and the outcome of this IoT thing, we are ready to move into the next part, and that next part is the genesis of IoT. Okay, so we've okay, anyone is having any question up till this point, you can type it. Give me 2 minutes. I think someone is banging on my okay. Now, before understand the IoT, we will also talk about a brief history or how the IoT things have been started. So here I have written the era of IoT is believed to be started in 8 or 9 but still, the I mean, it was started way back when we thought of having smart things, right, or the automated things. And it was started at that period of time, but the whole concept came into the picture in era of 8 and 9. And one of the major breakthrough was done by the Kevin Ashton. He was a supply chain management engineer at the Procter Gamble. I hope that this company is pretty much aware of you. You might be using some of the products. Okay, that is the different part. So he was initially, he thought, why not to connect all those stuffs to a automated mode, such that from anywhere I can access it and I can manage it. And then uh, it all started. First they have connected the supply chain to the internet, and after that it's all started, the story of IoT. Now, since we slightly are sorry, now we are aware of how the IoT have started. Now we will see how the other technology helps in forcing that IoT to achieve a new high. So when we talk of IoT, or the genesis of the IoT, or the history of IoT, or the evolution of the IoT, we must also discuss the other technology which are actively integrated in IoT system, and that is the internet, right? So now, next slide, we are going to talk about the internet and how internet helps us achieving the developing a new technology that is called IoT. So the evolution of internet can be divided, or can be characterized in four parts, and these are the four parts. Okay, so when the first internet came, we talk about the connectivity, and we always talk about the digital access. And I hope when you have internet, initially it was meant to send or receive email, uh, web browsing, or you are searching something on the Google, right? So initially the internet was for this only, right? Now this, in the second phase, uh, this internet itself, what it does, it helps on uh, uh, evolve a new technique or new technology platform that is called e-commerce. We all use these e-commerce websites for our day-to-day stuff process, like maybe Amazon, Flipkart, or maybe other things also. So now if you just see, firstly the internet was there. Initially it was believed to be used for the email, web browser, or the searching for some of the stuff, the things. But next page, what the same internet has does, they have evolved a new concept of e-commerce, digital supply chain, and the collaboration, right? In the next content, or in the next phase, we have immersive experience of internet, right? And we have the social media platform, mobility, cloud computing, and the video streaming, or the video exchange, right? So if you now, the next thing what the internet help us to develop is internet of the things. And what we connected earlier, uh, now from the internet of things we can connect anything, if we which can be physically realizable, right? uh, so if you see carefully, see, only the evolution of the internet help us developing many technology like e-commerce, digital supply chain, social media, cloud technology, video streaming, and now we have come up to the era of internet of things, right? I think someone wants to join. Oh, okay. So if you see, one technology, that is internet, helps us developing or evolving many of the technologies. Briefly, I'll explain whatever I'll explain for the previous figure. When we talk about the connectivity, the first phase, it's talk about the email and web browsing. Then we come to the networked economy, that is through the e-commerce and digital supply chain management. And then in the next page, we have extended the internet experiences for video exchange and social media connectivity, right? In the next page, we have a target of digitized world, and the digitized world will be, everything will be connected to the internet, whether it is a physical object, a machine, or a car, or you can imagine anything, you can connect it by some mean, right? Now it is very important working principle of IoT. Okay, so there are three components of IoT. The first is edge, the second is gateway, and the third is cloud. Right. Now we need to understand each uh, each of these components in great detail. This is another concept which we are going to study in the next 5 days. Right. To do this, let me share my whiteboard, and I'll also talk about so now we will talk of working of IoT. Right. So initially, when the IoT thing came into the picture, it was like if we have a sensor, and somehow if we send the sensor data to any storage, right, or maybe any application. Right. Now, when IoT starts, it was meant to send any one of the sensor data to the storage or the application, and then by the sensing, by seeing those data, we can make a decision, right? Now, what the sensor is sensing? The sensor is sensing a physical object over here, right? And so we have a physical object, right? And we want to know the property or maybe the environmental condition of this physical object. So what we do, we put a sensor, right? And this sensor sends a data to the user or maybe some of the application, right? And now after studying this data by this application or by the user will send a command this physical object, and accordingly we can manage the physical object. Initially it was the mood to how this sensor things work, right, or the IoT thing work. But later on it is realized that if we keep on sending sensor data directly to the end user or to the application, it will suppose a case that there are thousand sensors or maybe more than thousand sensors. So they will start spamming those storage, and it will be there are many redundant data will be there. So what they have done, they have come into the concept of the new technique, and that is called, first we'll have edge, then we have gateway, and then we have the cloud storage. Right. Now what happened, this edge will consist of many sensors. So let me have it, this edge has many sensors, and this edge will be only talking to this gateway. Right. Now the sensor will not talk to this gateway, only the edge will talking to this gateway, and this gateway will sending those information to this cloud storage. Now what will be inside the edge? Right. So first thing, inside the edge we can have a sensor. Okay, I'll write here a sensor. So suppose there are I can say we have, for example, we have 5 sensors, right? So there are 5 sensors which are which may be the of the different purpose. They are measuring different parameters, or maybe they are the same sensor and measuring the different physical conditions, right? It may be of both, right? So these sensors are sending the data to the gateway, right? And we have set the system such that it sends the data after, let us say, 10 minutes. Like it sends the data after 10 minutes. Right? It may happens that the physical condition which we are measuring with these 5 sensors are not changing within 10 minutes. Right? So what we'll get, we are receive the data at the gateway, same data, because the physical condition is not changing. And if the physical condition is not changing, the sensor will send the same signal or the same data to the gateway. Right? Now if we keep on sending the same data to the gateway will have report to the cloud storage, and the storage will be full of redundant data, right? So storage will be filled of redundant data, right? So now what to do? One thing will be either we can put a filter at the gateway, right? Or we can put a filter at the edge. Sorry. We can put a filter at the edge, right? Generally, putting a filter at the gateway is not advisable, because this gateway might have consist of many edges, right? I'm sorry. This gateway might consist of different edges, and for different edges, if you keep on putting the filters, the complexity of the gateway will be very much high. And generally the gateway is a typical router which you use for your day-to-day life, like your Wi-Fi router, or I mean everyone has the Wi-Fi router, right? So then it was advisable to use the filter at the edge, right? Now putting a filter at the edge will serve the purpose of filtering the redundant data, right? So suppose if your physical property is not changing in 10 minutes, and your system is configured such that it is sending the data in 10 minutes. So once the edge will design with a filter such that if there is no change in the data, it will not send the data to the gateway, right? So if it will not change the data to the gateway, and if there is a change in the physical property, then the edge will send the data to the gateway. Now, by using the filter, we have filtered that data, and only the data which is required to be sent to individual user or the application which we are measuring, right? Similarly, we can apply the filter over here and we can send the data, and again we can apply a filter over here and we can send the data, right? Now, this is the one objective or the one advantage of the filter, right? The second biggest advantage is when we talk of blockchain. I mean, in the coming, I think on the Thursday, we are going to have the blockchain class. So now when we talk about the employing the blockchain as the edges, we can apply at blockchain at the edges. And we'll see how to apply blockchain at the edges and what are the advantages. For the timing, I can say to provide the security of your data, right? And security is uttermost important because the physical object which you are measuring maybe consist of your private data or some personal data. So we still require the security that we'll discuss in the security class, right? So that is all about edge, gateway, and cloud. Now I'll focus on the edge. Of course, I'm going to discuss edge, gateway, and cloud in more detail. So now I'm talking about edge. So suppose I'm talking about this is an edge. So what we need to have in that edge, the first thing we need to have a sensor. The second thing we need to have a microcontroller. And third thing we need to have a processing device. Right. Now what sensor will do? Sensor will sense the data, and the microcontroller will program the data such that after how much time it need to sense on all the other things, it can be programmed. And the microcontroller may be at Mega or maybe Arduino Uno, and I hope everyone is aware of the Arduino Uno. So let me say this is Arduino. Okay. Now, what is the processing device and why we will require this processing device? Okay, the processing device is required to filter that data, right? So filter that data, and maybe we can apply the blockchain concept to sending the data from the edge to the gateway. That is why the processing device is required. But initially, it was meant to the filtering of the data, right? Next thing is the gateway. So gateway is nothing but is kind of your Wi-Fi router which receive the packets from the edge, different edge, and forward to the cloud. So now I'll go to the my slide, and we will talk about the edge, cloud, and the gateway in more detail. Okay. So whatever the things I have discussed in the, I mean, just now I've discussed is all about this edge, gateway, and cloud. So we will see edge, gateway, and cloud in more detail. So now I'm talking about the edge. So the edge is very nearly located to the physical object or the process, or maybe if you want, like suppose our internet IoT such that it was employed in the agriculture field, so we might be measuring the moisture in the soil. So the edge will be located very near to impact on the physical object, or very near to the process. As I have discussed, the edge consists of mainly two blocks: sensor and microcontroller, and local processing and storage block. Why I'm called it local processing and storage block? Because different edges will have the different local processing storage. I'll also discuss the what are the physical later on. I'll discuss no problem. So as I have discussed, the sensors generates the an electricity signal or electrical signal, which is very much uh, uh, related with the physical phenomena that we are intent to measure, right? And the second part, which is microcontroller, which is the second unit of the second block of the edge, serves the two purpose. It provides, first is provide the electrical power to the sensor, and second, it collects the electrical signal from the sensor. Now we might have a case where a microcontroller can integrate more than one sensors. So we can have, like suppose we have Arduino Uno, it has many input and output pins, so we can integrate more number of pins to that Arduino boards, right? Generally of course I have written in the slide that generally Arduino boards are the microcontroller are Arduino boards, but still I'm not going only to the Arduino board, because there are many microcontroller which is much cheaper to the Arduino boards are available in the market. The whole whole reason why I have written Arduino boards, because people are nowadays very much familiar with the Arduino boards, and they are easily available, and we can also find the programming of these Arduino boards. That's why I have written it, right? Now, after the collecting the data from the sensors, the microcontroller sends the signals to the local processing unit, right? And the local processing unit may be anything, your Raspberry Pi board, or maybe Intel Galileo or Intel Edison. It's depending upon what are the capacity of your IoT application, or how much data you are going to generate. Because how much data the local processing unit will be, you can have the local processing unit depending upon how much data you are going to generate from those sensors, right? Now what happens, so the local processing unit can be connected with a different sensors and microcontroller thing, right? So first thing, like suppose we have a microcontroller, right? It may consist of many sensors. Then we have a local processing unit, right? And we can have different microprocessors connecting with it. So the whole story is we can connect n number of sensor microcontroller combination with a local processing unit, and those whole combination we can call it as a single edge, right? Now in general, the local processing unit are having a small capability or a small computational power. And why I'm saying small computational power is, when we talk of IoT, one thing we need to focus on the low power consumption, and which is very much essential when we talk of IoT, or when we are designing the IoT, or when we are deploying the IoT, right? Now these boards which are available like Raspberry Pi or Intel Edison, which are having a smaller capacity in terms of computational power, but they also consume less power, and they are also very much handy, or maybe I can say the portable. For example, I can show you a Raspberry Pi board. Okay, for let me close this window. Now, first of all, I hope that this is a Arduino board. You might all have seen it. I'm just for the reference. I'm just sorry. For the reference, I'm just showing it. So this board, this is our. We can consider it is a microcontroller, and we can connect various sensor to this board. Of course, this price is around 400, 500. But still, if you want to develop your IoT thing on a large scale, you can go for the different microcontroller present over there. The second thing, that is the local processing unit, and for that I have a Raspberry Pi board. So you can see it is small in size, right? And it has enough computational power to process the data generated by various microcontroller and sensor block combinedly, right? Next, I'm going to talk about is the gateway. Okay. Okay. Now I'm going to talk about the gateway. The gateway, what happens when the local processing unit decided that this data is useful and it need to be sent to the application or the user, is just forwarded that data to the gateway. The gateway can be anything, your Wi-Fi router or maybe some other devices, right? But in general sense, the gateway are main supply powered. That we'll discuss in the next tomorrow's class. So generally the gateway are in the Wi-Fi, I mean the main supply power, and the main aim of the gateway is to collect the data from the edge or the different edges, and just it may happens that it can either directly process it, or it can store it and then process I mean forward it to the cloud. It's the gateway maybe of or both the types. One is it can directly get the data from the edge, and it can just forward it to the cloud. Or second, it may happen that it can get the data from the edge or the different edges. It has the storage, and if it has the processing power, if it can store it, process it, and then send to the gateway. So depending on what are the type of gateway is available, your data will be sending definitely your data will be going to send to the cloud. But a cloud can be very simple or maybe complex, depending upon your requirement. Like a cloud is generally your Wi-Fi router. So what your Wi-Fi router does, when you access the internet, it just connect to the internet by means of maybe like Wi-Fi signal or maybe other signal. Next thing, we are going to talk about the cloud processing and storage. Cloud processing and storage, I'm only going to introduce it. Some of the speakers are going to discuss much detail for the cloud as well as the different aspects. Okay. So we all know the cloud is a server-based storage, and the whole advantage of the cloud is we can access from anywhere if you have a active internet connection, right? And since we are able to access the cloud from any point, any place, we can manage our IoT application or IoT platform by any place just by accessing the cloud, right? So the what happens at the cloud, the data which is sent by the gateway will be stored at the cloud. They will process the data, they will aggregate it, and what they do after some times or after the aggregation, they will decide what to do for the physical object, or they will also do some of the prediction by using some of the algorithm, maybe machine learning or deep learning, something like that they can have. And we are going to study in the last day of this basically at the cloud we will store data for the long term, and the whole process of sending the data to the cloud is you might have the question that why exactly we are sending at the cloud. Because when the data is available on the cloud, authenticated user can access that data, visualize that data, and it can generate a command from that data. And in fact, it can predict uh, some of the behavior of your physical object. Like suppose you have employed a sensor in your ball bearing of your machine, and your sensor senses the health of that ball bearing which is running your the whole of the machine. And if by some means if your the health of the ball bearing is deteriorated, the sensor can sense the data to the cloud, and by using some of the predictive mechanism, the it can be the user can generate, or user can decide, okay, after 10 days or maybe 20 days we are going to change the ball bearing. This is a small example. This example can be like anything. For example, three of my students are developing a technique to by using the IoT to predict the heart rate, heart failure in much advance, right? So still we are in very initial phase. We have developed the predicting algorithm. We have also developed the hardware components, which are the components, and now we are in the process to integrate those algorithm, machine learning algorithm to that hardware thing. And if all goes well, we will be going to develop a very cost-effective tool to predict the heart failure rate, heart failure in much advance. So this is the one example. I mean, you can give your student many applications. I mean, the application of IoT is very enormous. I mean, it's huge. I mean, whatever the situation you can imagine, you can take you can employ your IoT things, and you can try to manage that. Okay. Now, briefly, I'll talk about the IoT and digitization. So, IoT and digitization cannot be, I mean, mostly the people use both these terms interchangeably, but there are key differences. The digitization and the IoT has the key differences. And digitization means whatever the data or whatever the information you are getting, you can convert into the digital form. But IoT is a whole kind of process which can integrate the unconnected things, and or the processes, and when we can have those things and processes combinedly together, and we can utilize those things and processes for our uh, different purposes. For example, digitization. Earlier we have a rolled camera, and now we have a digital camera. This is a kind of digitization. Okay. Now we'll talk about the impact of IoT, because any technology which is evolved, or which people are used to develop the new technology, there must be a future and impact on the society. Right? So the impact of IoT can be it is very huge. I mean, in Cisco system predicts that by 2020 itself, it's 2020, so 50 billion devices will be connected to the IoT. A recent report in UK government tells us that more than 100 billion objects will be connected in coming 5 years. And of course, the money involved, or it's the economy, the well, IoT economy will be $19 trillion. So you can imagine how much jobs the IoT is going to create. But still, all those the impacts is not only for the generating profits on, not only for the uh, 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 what I say, not only for the uh, big corporate saving or the getting out of the profit of that. IoT can be also utilized for the betterment of the humankind, or we can serve by the mean of IoT to the uh, to the poor people of world, or maybe India also, because we are also not developed country. So still there are many areas where we can employ our IoT thing, and we can have the betterment of our own people, right? This figure shows, just see, this figure shows how IoT and other devices have evolved. Sorry. So in 2003, uh, in a general, for every person we have one of the maybe each person is having one of the phone. Next, we have evolved to 2010, and a person might be having two phones. Right? Now, if we see in 2020, our population, the world population is only maybe around 6.5 billion, right? And if you see, already 50 billion devices are connected. So now you can see more than 7 times the population of world we have devices, and all those devices are connected with the Internet of Things or the internet. So you can see how much data these devices will generate. And if these devices will generate the data, or if we employ these many of devices, we can say how much automated our life being through the IoT. Still there are many challenges in IoT, we'll discuss later on. Okay, I'll talk about some of the examples of IoT, right? So these examples consist of, I mean, I have only taken 4 of the examples, but there are a lot of examples for IoT. Now I'll firstly talk about the connected roadways. Okay, so all of us are hearing about the self-driving car or autonomous car, right? So what happened? These self-driving cars or autonomous cars, they will have many sensors, and the sensor sense the data or the physical condition of that particular place, and accordingly the car will be given a speed, or maybe direction or something like that. We will give or drive the car automatically. So whole story is that there is a sensor, there will be an edge, and there will be gateway, then there will be cloud, and all those data will be streamed to the cloud, and from there on the cloud there will be algorithm which will be running to predict the next outcome and direct those cars according to that data which we are gathering from the car, right? This is a Google self-driving car. So you can see this over here, the black color one over here. This is serve as a uh, router to the cloud, and this car have many sensors, it sends the data, and this gateway we can send to the cloud, and then it receives the response from the algorithm, and then the car will be driven accordingly. That is the one case. The second case we can, okay. Okay. Now, before going into the second case, what are the advantages of a connected roadways? So according to the recent sorry, according to the recent Government of India data, every year around 5 lakhs accident takes place, and these accidents are causing 1.5 lakh deaths. So if we employ our IoT thing to the connected vehicle technology such that it can warn the driver, or it can uh, intimate the driver in well advance such that a collision is going to happen, uh, it will be very much easy. I mean, it is very much useful to reduce those accidents. You might have been seen many videos that there we have a self-parking cars. I mean, there are few cars which is having system of self-parking. That is nothing but a connected roadways or connected car kind of thing, right? Suppose there is an accident on highway, and you are driving through that highway, and there is accident maybe after 4 or 5 kilometers you are going, so when you are driving towards the accident side, if there is an accident and if road is connected, or there is a integration of the road to the cars, your car will get a signal at 4 kilometer ahead there is an accident, and you can take this route or maybe this route, right? One can argue that by seeing the Google map, we can see there is an accident or not, right? But when you're while you're driving, you cannot always have the Google map, and you can always not focus on the Google map, because uh, uh, there may be a chances of lack of concentration on driving, and you might ended up with accident. So if your system itself automatically give you a response that there is an accident at 4 kilometers, so you might take different path. Similarly, the mobility part, if like we have more than billion cars on the roads, I'm talking about worldwide. So if there is any congestion or any different kind of things, your car will automatically get a signal such that there is a congestion on this road. It can automatically direct it to a different road, which generally Google does, right? But there is a still there is a gap of Google map. You might have been experiences like many places, the when you started from your home, it shows the traffic is not there in bit, but when you reach at the actual place, there was a traffic. So there is a lack of lag from the Google itself, right? And if we successfully manage to avoid those traffics, you can serve the purpose of saving or reducing the CO2, which indirectly will good for our environment. Now the second example of IoT is the intersection movement assistant. So what it does, it sends at this intersection, if you see at this intersection, right? So at this intersection, we can see a car is approaching that intersection, and in between a person on the bike is already there. So the system itself sends alarm to the car as well as the bike person that if you need to break it, otherwise you are going to have a collision. So something like that, a small thing can help us avoiding those accidents. This is the other example of connected cars. I mean, there are many sensors and integrated. And now I'll talk about the connected factories. And you might have heard a term of IIoT, right? So what is IIoT? So Industrial Internet of Things. So basically, in most of the manufacturing factory, the whole process is manual, and manually the people are managing those machines. Manually they are examining the condition of machines, and manually they are doing all those steps to produce any object, right? But in manual things, there may be a misjudgment, or they might miss some of the issues which machines have. So which can harm the productivity of that company. So now the companies are employing those sensors and IoT things to improve their production, the quality, and at the same time they are decreasing the production cost of any material, right? And in fact, if you want to produce manually, it may happen that many the things which are produced by that company might be defected, or something like that can be happen. So those losses can be minimized by using the efficient use of these technologies of IoT. Okay. So these are the this is one of the example how industry evolved. So in 18th century, there was a mechanical assistance. Then 20th century, we have talked about the mass production, and then we have the electronic control and all. And now we are moving up to IoT integration for those big companies, and that the production will be there will be massive fold increasement in the production as well as the quality. Now I'll talk about the smart connected buildings. I hope many of these cities now they are having the smart buildings. There are also smart refrigerators, smart ACs are there. I mean, I'll not discuss much detail after the on this part, but what I'll going to discuss is interesting thing is smart creatures, right? And why I have put this in small creatures are, up till now, when we talk about the Internet of Things, we are only connecting uh, the things which are not live, right? So what they are like, suppose initially we have started with things like physical things like the chairs, benches, and then there we implying those sensor and getting some of the data, right? But now we are focusing on, we are connecting a sensor on a living object. So what happens when you connect focus on connecting a sensor on the living object? There is a new dimension, and this is called smart creature. Now I'll give you the example. The smart creature was started by a Dutch company, and what they have done, they have placed sensors in the ear of cows in a dairy farm. Sorry. So what happened? They have placed sensors in the cow's ear, and by those sensors, they are monitoring. From those sensors, they are monitoring the health of that cow, and they are taking the predictive action such that the milk productivity of that particular cow can be improved, or it cannot be degraded. And by employing those sensors and IoT thing, they are successfully improved the milk productivity of the cows which are at that dairy. And frankly telling, in India also we are having, sorry, in India also we are having the same smart cow. In many dairies in Punjab, people are employing those sensors. Uh, Unknowingly, they say it's a kind of device which monitor the health, but basically those are the sensors. Basically, they employ maybe on the ear or maybe on the neck of the particular cow, and they used to monitor their health, and accordingly they will improve the productivity of the milk. The second most uh, important example, which recently one of the researchers group they have employed, is they have placed they have placed uh, this figure. It might be scary to some of you, but pardon me, but they have placed a small device on the back of a cockroach. And why they have placed it? They placed this device on the back of the cockroach to serve any living human when there is a collapse of building or when there is a disaster, right? So this device is having an antenna, it's having a microphone, and uh, what happens by this device, uh, we we used to guide this cockroach, or the researchers have used to guide the cockroach to any particular direction for any particular movement, right? So you might have been seen that cockroaches have two small open, I mean the rods kind of things, and we usually also call it an antenna. So when there is a surrounding present over here, so by those sensors they sense it, and they detect there is the okay, there is an object, I need to move at this place. So what happens, those researchers just see, uh, okay, these are the two sensors which are natural sensors of cockroaches. So what they have done, they have connected these two sensors to this device, right? And they manage the signals from this device to these sensors. So suppose I want to move, like suppose it is moving in this direction, and suppose I want to move this cockroach in this particular direction. So what I'll give, I'll send a signal over this place, right? So this cockroach itself detects that is there in an obstacle at this place, so it will start moving in this direction. If we want to move in this direction, we can send a signal at this antenna or sensors, and then the cockroach will sense, is it is there a screen over there, okay, since there is an obstacle over there, so it will move in this direction. Now by guiding this cockroach, and they have ability to penetrate in small spaces, so by guiding these this approach, we can send this whole pack of the cockroach plus the device to the rubbles of that a collapsed building, and then by directional audio, we can sense if there is a person living or a living person present in that rubble or not. So these techniques, earlier to do that, we have that sniffing dogs that used to sniff it, but still if the building, the collapse is huge, the sniper dogs will not be able to sniff it, because uh, there may be a whole huge rubble over there, that person. So this they have employed it, and they have successfully directed that cockroach to find the any person in the rubble. So this is one of the example. Accordingly, uh, you can imagine your situation, you can design your things, right? Now I'll briefly talk about the challenge, and then we'll break for the lunch. Okay. So still we have IT networks, which is still large, but the of OT, which is consists of IoT, that is called operational technology. So which it is a huge. Security is a major concern. We are going to discuss in much detail, because for today's scenario, designing of an IoT is a small part, securing that IoT is a bigger part. So when as a enterprises or a researcher, when you thought of developing, or if you think of developing any of the IoT product, you must focus on the security. Privacy is also one of the concern, because we are sensing uh, more of the private data. Like you might have seen the advertisement of iPhones. They usually talk about not much detail about their technical specification. They talk about their privacy, right? Of course, as we have seen that the IoT are generating large amount of data, and we might have been ended with, maybe in the 5 years we have 100 billion devices connected, and those devices or those IoT things will be generating a huge amount of data. So to manage is to analysis it, we need to have the big data analysis and a different algorithm. Interoperability, which is the major concern of today's IoT design part, because uh, various companies are there that they are defining their own standards, and they are by their own standard they are making different IoT platform. They are making different IoT products, but still there is a need to have an interoperability thing, because if there is not interoperability, we cannot integrate the IoT things of two others company, right? So there will be a monopoly. If you buy a product of my company, the other product you should buy from my company itself. So interoperability is a major concern when we are designing the IoT thing, right? So in the summary, what we have looked of, uh, what is the Internet of Things, and how what are the working of the Internet of Things, and if we by somehow, if you manage or we can employ intelligent network, we can control the physical aspects of uh, any process. And we have learned a small concept or a small term, which we are going to use the use in the future. Before ending that whole thing of the IoT of today's, I mean, this 5 days course will be evolved Unfortunately, there was a connection problem at my end. So, can someone tell me at which point my connection was off? Summary. Okay. So I'll come to the summary. Okay, no issues. Sorry for the inconvenience. So I'll share my slide. I hope it is visible. Okay. Okay. So what I was summarizing is we have learned the term of Internet of Things. We have seen some of the use case scenario, and we have learned different things, right? But whole of this 5 days lecture will be moving through uh, this part. So we'll be talking about the sensors, how sensor connect to this local processing unit, how there is a connection between local processing unit to the gateway. We are also going to talk about the cloud processing, different algorithm, and we are also going to talk about how algorithm can be developed in machine learning and deep learning. And most importantly, we are also going to see the security of IoT, right? So all those things we are going to see in the coming 4 days, right? Now, if you have any question, you can type here. If you have any question, please type over here. One of the, okay, I don't get clarity regarding applying filter. What is the blockchain at the edge? Okay, okay, no issue. So what happens? Okay, I'll answer one by one. So one of the thing is applying the filter. When initially when I talk about the applying the filter, that means we are going to have uh, uh, a local processing unit. Now this local processing unit is used to send the data to the gateway, right? So if we use uh, a conventional security thing or the security application, there might be a possibility of hacking those data. So now the blockchain is one of the concept which is used to securing the data or encrypting it. You might have heard of the cryptocurrencies. So similarly, we are encrypting those data and sending to the gateway. So that is the one example of using the blockchain, right? Now I'll come with the to the second question. What is blockchain at the edge? Okay. The second question is, what is blockchain at the edge? So basically, now researchers have focused on using blockchain at the edges to secure those data, which I've already told you, right? So it's all process of making your IoT device secure. Now the second is cloud mandatory to have IoT setup? Of course, okay. Uh, I'll come to the, okay. So to be very frank, if your IoT thing is very much local, you might not be have to require this cloud, right? But if you're thinking of IoT which it's all full scale, or maybe accessing those things from a remote location, or maybe have a big processing power, you might require cloud. Okay. I think third question, how can blockchain scale at the edge? Of course, when the blockchain will be discussed, it will be discussed in more detail, right? So I hope your question will be answered at that time. But still, believe me, people are now using blockchain at the edges. Now the next question is, how we can differentiate the edge, fog, and cloud competing with the difference experience. Of course, very good question. This all those things will be discussed in the coming next lectures, so you'll be having the clarity on that question, that point. Now next question is about the machine learning. Of course, we are going to use machine learning, because when we are going to predict something, or you are going to employ some of the algorithm, you are going to use machine learning. So of course, at the okay, apart from Raspberry Pi, what else can use? Intel Edison can be used, no problem. Okay, I was talking about the machine learning. So machine learning will be employed at the cloud end. So at the cloud end, you can employ your machine learning algorithm to predict your physical object condition in the future. Uh, more questions? Okay, no issue. So what we'll do, we'll meet at 2:30. Thank you. So we'll break for lunch. Okay, your attendance will be directly, I have a software which your attendance will be directly captured when you have joined and when we have left. Okay, thank you. Thank you very much.